All right, in this video, we want to work on operations on functions represented by formulas. So we've got two linear functions to work with here. And I've got three of our four operations. I did subtraction, multiplication, and division. Addition is going to be very similar to subtraction. So just remember here that f minus g of x is the function you get by taking f of x and subtracting g of x. And we can refer right back up to our function rules. F of x is the function 3x minus 2, and g of x is the function negative 2/3 x plus 1. And we want to really commit to those rules again, just like anytime we hit function notation, we're using formulas. Function f, no matter what we give it, it will give us back 3 times our input minus 2. And function g will always give us back negative 2/3 times our input plus 1. This time we're just giving it x, so that makes it really easy. When you give x to function f, it gives you back 3x minus 2. And when you give x to function g, it gives you back negative 2/3 x plus 1. As always, it's never wrong to throw some parentheses around your outputs or your inputs, but in this case, it's our outputs that we're manipulating. Sometimes they're not necessary. That's true for this first set. We don't really need those. There's no operations, there's no multiplication, there's no exponents, there's no functions. But the second one really does matter. That minus sign will need to distribute through. So if we'd failed to include the parentheses, we probably would make a mistake with that sign there. So we want to be careful. This will turn into 3x minus 2 plus 2/3 x minus 1. The negative 2 minus 1, that's not so bad. That's a negative 3, but the 3x plus 2/3 x needs just a little bit of thought. We're going to have to multiply that first one by 3 over 3. So we have 9/3 x plus 2/3 x, which will be 11/3 x minus 3. And that is the new function f minus g of x. And again, we have the two notations. So we have the, I can get my highlighter, there we go. The f minus g of x notation. And that's just emphasizing that this is the new function named f minus g. It does also show you how we got that function by taking f and subtracting g, but it's just emphasizing the fact that it's a new function, whereas writing this f of x minus g of x is emphasizing that we're subtracting one function from another a little more, separating them a little more. So that's all we're trying to do with this kind of funny looking notation. It's nothing too big, but a little bit subtle there to think about. For f times g of x. So again, what that really means is take f of x and multiply it by g of x. And again, with the notation, we're just emphasizing here that f times g of x is a new function. So we will take that formula for f of x, 3x minus 2, and multiply it by that formula for g of x, negative 2/3 x plus 1. And really that's okay like that, but I'm going to go ahead and multiply it out because we're definitely going to hit these where we're going to multiply them out and simplify. So this is basically just foiling our first two, 3x times negative 2/3 x. That actually works out really nicely. We get a negative 2x squared. Our outer, excuse me, is a 3x. Our inner ends up being positive 4/3 x. And then our last is negative 2. And I can do just a little bit better and make that a negative 2x squared. And then 3, so that again is 9/3 x plus 4/3 x. So I think I'm seeing 13/3 x minus 2. And I usually do put the parentheses around here, but just in case you do see it in your homework where there are kind of a mix of notations, which I think is probably good for you, sometimes you'll see it without the parentheses as well, and that is okay. Okay, last one, and something a little bit interesting happens with this last one. So f over g, and that really does mean take f of x over g of x and create this new function f over g. f of x is a 3x minus 2. G of x is a negative 2/3 x plus 1. And this actually isn't far off from being fine as is. The only thing I don't like is the fractions within fractions. So I'm going to look at this 2/3 right here and say, okay, I'd really like to eliminate that fraction. So I'm going to multiply top and bottom of the big fraction by 3. And I get 9x minus 6 over negative 2x plus 3. And that I would say is great. I don't think you need to do anything else with it. Do check on these. One thing that looks a little bit like I should at least think about it, I could factor a 3 out on the top. And it's not that you have to factor something to make it simplified. It's just that you're checking to see if you can cancel. And it actually is kind of close, right? But it's a 3x minus 2 and negative 2x plus 3. So the sign I could fix, but the fact that the 3 is connected to the x in the first one and the 2 is connected to the x in the second one, that's not going to fix. So I would say I don't need to factor unless I can cancel, so I'll just leave it like that. Okay, there is one more thing I want to start bringing up here. It's not a very interesting question until we get to some more complicated functions that have domain restrictions, but I just want us to start thinking about it. When you combine two functions, you can create a new function and it potentially has a little bit different domain. So when we're looking at f minus g, it really is just the domain of f and the domain of g that you need to check, make sure you don't have any problems. And here we're working on two linear functions. So domain is all real numbers, and we haven't created any new problems by subtracting the two all real numbers. So again, not terribly exciting, but just to start to kind of pay attention. When we multiply, it's going to be very similar. We can look at the two original functions and say the same thing. No domain restrictions, no domain restrictions. And when we multiply them, it doesn't introduce any new domain restrictions. So this is still in all real numbers. The third one, though, is the first one we hit that is a little bit interesting, and we'll keep adding to some of this thought about domain as we go. For the third one, we're starting with the same two basic functions that have no domain restrictions. But by the time we simplify, we can see that we do actually have one thing to check when we're checking domain of formulas. For now, the big things, and we're going to add one more to the list, but the first two are pretty easy to think about. The big things that we would run into are square roots of negative numbers, or fourth roots or sixth roots, even roots of negative numbers, or division by 0. And we potentially could have that. So when you're dividing two functions, even if they have really nice domains, you're going to possibly introduce a restriction just by putting one of them in the denominator. So we could find that sometimes just by inspection. Otherwise, we could say, well, we want to make sure that negative 2x plus 3 is not equal to 0. And you can solve that inequality. You could add 2x to both sides and divide by 2 and say, okay, this one actually does have one domain restriction. And just like that is fine. X does not equal 3/2. Do be clear that when you're saying that, you're saying x can be absolutely anything but 3/2. So if there's any other restrictions, we need to list with that. But in this case, that really is what we want to say. We can plug in anything at all except for 3/2. Okay, so that's how formulas are going to look. You maybe see a little bit of absolute value or quadratic mixed in, but we won't mix in the messier functions until a little later on.